Okay, so in this question, we have two logs. We have the log of x plus 5 minus the log of x plus 1 equals 1. Okay, so how are we going to do this? How are we going to just, in fact, you know what I'm going to do? I'm going to make this a 2 just to make the problem more interesting. Let's make that a 2 over there. All right, so how do we do this problem? Well, if you look down the notes, here's the exam 4 notes. Solving two logs added or subtracted. That's what we're talking about here. Step 1, combine the two logs into one log by the log properties, which means adding becomes multiplication, subtraction becomes division. So if it was subtraction, then it would become division. So that's what we got to do. That's step number 1. Combine the two logs into one log by the properties. Adding becomes multiplication, and subtraction becomes division, right? So we've got subtraction here. So when we go to one log, this is going to become division, isn't it? Are we good there? See how subtraction became division. So in other words, an easier operation for two people, two logs, just subtraction, adding, subtracting. You learned that when you were like first grade probably. Becomes harder, division, that wasn't maybe till 4th grade. A harder operation for one person, harder job for one log. Okay, so there we go. So we combine the two logs into one log by the properties. We did it. So two logs become one log. What's our next step? Put in the invisible base 10 and then swish it. So step 2, invisible base 10 and do the swish. Put in the base 10 and do the swish. At which case you lose the log, right? So I'm going to write it here again. Log of x plus 5. Getting kind of scribbly here. Log of x plus 5 over x plus 1 is 2. All right, I'm going to put in the base 10, and then I'm going to do the switch thing. You go boop and boop like that. Right? So it's going to become 10 to the 2 equals x plus 5 over x plus 1. That step makes sense? So, and I lost the log word, didn't I? You lose the log. When you do that step, you lose the log. So you put in the base 10, put in the base 10, and you swish. 10 to the 2 equals x plus 5 over x plus 1. Like that. Okay. And so then what is that? 10 to this, oh, and then what do you do? So what's next? Let's keep going. Step 3, multiply out both sides. Oh, well, that's gonna be a little different in our case. Let me show you what we're doing. So now we just, step 3, multiply out. So what is 10 squared? That's 10 times 10. That's 100, isn't it? 10 squared is 100. Okay, now in this case, how do we solve two equal fractions? Remember what you do? You put this over 1 and you cross multiply. So I'm going to go diagonal, diagonal. So I'm going to get 100 times x plus 1 is 1 times x plus 5, distribute 100x plus 100, boom, boom, whoops, which is x plus 5, like that. Okay, and now how do we solve for x? Cross multiply and then just solve for x. So what do you do when you have x? This is a 1x. The other side has 100x, so let's subtract 1x from both sides. Boom, boom. So we get 99x plus 100 is 5. Is that good? 100x minus 1x is 99x. Trying to keep going to solve for x here. Subtract 100 from both sides. Boom, boom. So we get 99x is minus 95. Last step. Divide by 99. There it is. X equals minus 95 over 99. Now let's go back for a second. Now you might say, wait, Mr. Heron, didn't you say that the inside of a log can't be negative? It says something about that down here in the notes. Where is it? Yeah. Keep only answers which do not make the inside of a log 0 or negative. Remember that log of 0 or negative is undefined. So in my example, you had to throw away the negative. Now you might say, oh, well, this is a negative answer. Let's throw it away. No. Careful, not quite so fast. It says exact value or round to 4. So now let's just go and get a decimal, and I think you'll see what I'm talking about. So if you divide that on your calculator, I'm going to do it right now too. I'm getting negative 0.9595 9. So it good enough. There's 5 decimal places. So anyway, it just keeps going 95 forever. So now is it okay? Let's read carefully. Let's read the fine print carefully. It says keep only answers which do not make. Makes a big word. We're talking about not just what they are, but what they make. The inside of the log 0. So it didn't say, the sentence did not say only keep positive answers, please, or don't keep answers that are negative or 0. No, that's not what it said. It didn't say keep only answers which are not 0 or negative. It said keep only answers which do not make the inside of it. Well, what do you mean make? Meaning if they're plugged in. So if we go back to the, what was the original question? This one, log x plus 5 minus log x plus 1 is 2. So if we go back to the beginning, we say, okay, so the original question here. So here's the original question. Log x plus 5 minus log x plus 1 equals 2. Did I get that right? X plus 5, I think that's right. X plus 5, x plus 1, 2. Right, minus in between. Yeah. Anyway, so the question is, if you were to take this answer and plug it in for x, remember we're saying that's what x is, right? X equals that. What would it make of the inside? Well, it would be just fine. Let me show you. Minus 0.95959 plus 5 minus log, and what would happen here? Again, x is minus 0.95959 plus 1, right? Well, subtract that on your calculator. I don't even know what it is. It's 4.0 whatever, blah, blah, blah. I don't even care. And what is this? 1 minus 0.9. So this is going to be positive 0.0. I think it's 4, blah, 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 blah. So my point is, look here. Take a look with me here. This is positive. The inside is positive in both cases. Do you see how? So this answer is okay. So x equals minus 0.95959 is good because it did not make the inside of the logs 0, come on, or negative, right? They're both positive. You tracking with me? So you don't have to do all this if you can just look at that number, go, look, it's negative 0.9. It's not even negative 1. So put in here next to 1, it's still going to be positive. This one for sure is positive because it's 5 minus it. It's a keeper. You don't have to do this if you can just see it. If you can just look at this answer and go, oh, he's not going to make the inside of any log 0 or negative. Even though he himself is negative, he doesn't make the inside of the log negative, does it? When you put him in right here, +5, it comes out positive. When you put him in here, +1, it's still barely positive. Inside is positive. So it's a keeper. It's a good answer. So what's the real answer? It's that answer. That is the right answer. It's a keeper. We don't throw it away. So what that rule is saying, let's look back at the fine print again. Keep only answers which do not make the inside of a log 0 or negative. So we keep it, don't we? We keep that answer. It's a good one. He doesn't make, when plugged in to the original for x, when we say x equals that, and you plug it in, it doesn't make the inside. The insides come out both positive, not 0, not negative. So that means it's an acceptable answer. This won't give you an error. You can do this, log of this and log of that on your calculator. It won't be an error. It's good. It's acceptable. All right, so once again then, how do we solve a log equation? What do we do? Well, when you've got two logs added or subtracted, first step is to combine them. Adding for one log becomes, for two logs becomes multiplication for one log, or subtracting for two logs becomes division for one. So 2 logs subtracted becomes division for 1 log. And then you put in the invisible base 10, you do the swish, and it's bye-bye log. That changes from log form to exponential. So we get 10 to the second is this, 10 to the second is 100. And then you just put that over 1, cross multiply, we get this, distribute, get rid of the x on both sides, solve for x, get x alone, there it is, there's x. And it turns out that's it, that we keep that negative answer as acceptable because plugged in, inside of the logs still remain positive. So that's a valid answer. And there we go.